Okay, in this video, I'm going to be looking at the derivatives of logarithmic functions. Okay, and we've got our little table here to go through the basics of it. And when it's just ln x, so remember ln is another way to write log e. Okay, so remember log in base e is the same as ln. So when I see log e x, it's the same as ln x. We know the derivative is just 1 over x. Okay, and when they're a bit more complex, we've got sort of a chain going on as well. So when it's ln of something a little more complex in terms of x there, it is still 1 over f of x. It won't be x in this case. And then you times by f dash x. So just important to realize that when you times by f dash x, it goes on the numerator, whereas the f of x goes on the denominator. All right, we'll just do a quick simple example of that. So for example, if I got ln 3x plus 2, you would find that the derivative of that will be 1 over that stuff inside. You see that? So it's 1 over this. Now we times by that chain. So the derivative of 3x plus 2 is just 3. And like it says there, we can just write it like this. So the chain becomes the numerator, right? And the thing that was inside goes on the bottom. All right, so in this first one, it's sort of just trying to show you a quick little rule. Might help you with transformations later or whatever, but find the slope function of this guy. So dy by dx will be 1 over the stuff inside, and then you times by the derivative of kx. So k is a constant, right? So the derivative of kx will just be k. And it's interesting to note that I guess we could rewrite it like this. It's interesting to see that you could cancel, and it's interesting to see that's 1 on x. Now, if you look at your rules up here, you'll see that actually that's quite interesting. So what they're saying here is the derivative of ln kx would be the same as the derivative of ln x. That's an interesting point to know. All right, let's have a look at this next one. Okay, we've got the derivative of ln 1 take 3x, so dy by dx. So we put 1 over what we've got inside there, okay? And then we times by the derivative of 1 take 3x. The constant will be 0, so we'll just get negative 3 there. All right, it's important to note there's no constants out the front. You know, if you had like y equals 2 ln 1 take 3x, okay, the constant just stays out the front, right? So you'd have dy by dx would be 2 times 1 over 1 take 3x times minus 3, right? You just need to realize that the 2 and the minus 3 are numerators, whereas the 1 take 3x is on the bottom, okay? All right, next one, we've got, I hope you can spot it, it's a product rule, okay? So we have to break them up. So the first one is the x cubed, and the second one is ln x. So u prime, or u dash, is 3x squared, and the derivative of ln x is 1 on x, okay? So in the case of this, dy by dx will be u dash v plus ub dash. So u dash is 3x squared times ln x. Put a plus between them, and then we've got x cubed times 1 on x. There could be some tidying up of that later. We'll just leave that for now. We're just going through some of the rules. Okay, well, let's have a look at the next page. So with these ones here, they are slightly different, okay? And we've got some rules down here. Do you see these? Employing these log laws would be very useful. Because if you try and diff this, it would be very complex. I mean, if you started, it would be 1 over the stuff inside. And then I don't know if you can spot, if you have to do the derivative of that, it's going to be like a product rule, okay? So, a product would be the diff of the first one, right? And then times the second, then it'll be the second times that, okay? It's all getting quite complex, right? So what we suggest you do is when you see something like this where there's sort of a product in there or a quotient, so you see in the second question below, there it is here, there's a quotient, we employ some of our log laws, and they're here, okay? So it basically says when you've got ln something where there's two things multiplied together, you can break it into two separate ones, okay? There's no number at the front, it's just one, okay? You can't have a number at the front. And similarly, when you've got a division, we can represent that as two logarithms with a subtraction between them, all right? So what I'm going to do is break them up. So you can see we've got x times e to the minus x. So another way to write that is ln x plus ln e to the minus x, okay? There's even more rules you could employ here. It's not written there, but you may remember that the rule here, you can put the power out the front, right? Okay, and also that ln e is equal to 1. So you can actually just write that as take x, right? So like I said, when you've got ln a to the b can go out the front, right? Okay, so you can employ those logarithm laws here, and it just turns out when I put the minus x out the front, right, what we're left with is ln e, and from your log laws, you should remember that that will equal 1. Okay, so if that becomes 1, you're just left with take x. All right. So once I've actually got that in that place, it becomes much, much simpler to diff, right? So we've got the derivative of that. So dy by dx is equal to just 1 on x, take 1. And that's very useful when they're more complex. You know, you could have actually found the derivative even at this stage, right? So you could have actually had dy by dx equals 1 on x. The next one would have been, remember, it's 1 on that thing, okay? And then you times by the derivative of e to the minus x, which is going to be e to the minus x times minus 1. It's kind of weird, but I don't know if you can see e to the minus x over e to the minus x is 1 anyway. Okay, you are going to get the same answer. All right, so try and use the log laws to break these up, and it will make your life a lot easier. Let's have a look at this second one. Okay. So sorry, guys. So in this case here, we've got like a subtraction, right? So you see we're going to use this simple rule here. So I've got y equals ln. So I've got the top divided by the bottom, right? So that's all sort of in a super bracket. Okay, so I'm using that second rule where I've got x squared divided by that bottom part can be written as that. Now what I could do is even break that up even more. Okay, I could have, like I said, that power. The power could come out the front, so it's really 2 ln x. And this here, have a look at this. We've got two logarithms multiplied together. Do you see that? We've got ln x plus 2 times ln x plus 3. So we could split that up into two separate ones, okay, with an addition. All right. So here I'm employing the first rule where if I've got two things multiplied together inside, we can break it into addition. Just note the subtraction out the front. Yeah, so don't forget, we didn't write it down here, but we've also got the ln a to the b rule where it can be just the b goes out the front of the power, right? Okay, so there's the power going out the front. All right, now that it's in this form, let's just tidy up that back bit. Okay, so I've got y equals 2 ln x, take ln x plus 2, take ln x take 3, because there's this subtraction out the front. And we can find dy by dx. So dy by dx will be, here we've got a constant out the front, so just leave it there. So the derivative of ln x is 1 on x. Now you've got a negative 1 out the front, so just think of it as negative 1. Okay, the derivative of ln x is going to be 1 over x plus 2. Okay, there's no real chain here. The derivative of x plus 2 is just 1. And then it's negative 1 as the constant at the front, and then over the derivative of ln x take 3 is 1 over x take 3, and there's no real chain here. All right, you can't really do too much else. You could just write it as 2 over x, take 1 on x plus 2, take 1 on x plus take 3. All right, probably could have done a few more with constants, but it's just an introduction. So remember, the derivative of ln x is always 1 over it. And don't forget to do a chain if you need to. And you have to start using log laws to make your life easier here. All right, so have a go at some of these and remember to use the log laws when you need to. Okay.